PNS Khaibar completing its firing tests represents one of the most significant milestones in the life cycle of a modern warship, an achievement that reflects an extensive, detailed, and methodical evaluation of every system, subsystem, and operational procedure on board. The journey to this point begins with the ship as a physical structure, built from thousands of components, each with a precise function, and each requiring careful integration into the larger whole. From the hull itself, designed to withstand extreme sea states, to the propulsion system capable of generating sustained power over long missions, every part of the ship must perform reliably before live fire exercises can be considered. The hull's integrity is tested to ensure it can resist the mechanical stresses of high-speed maneuvers, the rolling and pitching of the sea, and the vibrations and forces generated during weapon firing. Its structural design also accounts for survivability, ensuring that compartments, bulkheads, and critical systems can remain operational even if damage occurs in combat conditions. Propulsion systems, including gas turbines, diesel engines, or combined systems depending on the ship's configuration, are tested extensively to verify not only maximum speed and acceleration but also efficiency under different loads, fuel consumption, and maneuverability. The engines must respond instantly to orders, accelerate and decelerate the vessel smoothly, and maintain stability even while operating complex onboard systems at peak capacity. The power distribution network is another critical area. It must provide uninterrupted electricity to all weapons, sensors, communication devices, radar, sonar, computers, lighting, and auxiliary systems. Redundant circuits and emergency power backups are tested to ensure that no single failure can compromise the ship's ability to detect or engage threats. The ship's navigation and communication systems are also evaluated in the early stages. These systems include satellite navigation receivers, inertial navigation systems, gyro compasses, automated charting systems, and internal communication networks that link every department of the ship. During trials, the ship must demonstrate precise course keeping, accurate positioning, and the ability to maintain coordination with other vessels, aircraft, or command centers over long distances. Redundancy is tested by intentionally disconnecting certain subsystems to ensure the ship can continue operations without loss of function. Sensors are then tested individually and collectively as integrated systems. Surface search radars must detect small and large targets at variable distances, in all directions, and in diverse weather conditions. Air search radars are tested to identify fast-moving aerial objects, drones, and low-flying threats while filtering out irrelevant signals. Electro-optical and infrared tracking systems are calibrated to provide real-time imaging, accurate targeting data, and resilience under glare, fog, or low-light conditions. Sonar systems, which detect and classify underwater objects, are evaluated for their sensitivity, range, accuracy, and ability to discriminate between genuine threats and environmental noise such as marine life, ocean currents, and seabed formations. Electronic warfare systems are similarly scrutinized, requiring the ship to detect, analyze, and respond to potential jamming, spoofing, or other electronic attacks. These systems must be precise enough to protect the ship while ensuring that they do not interfere with its own sensors, weapons, or communication links. The combat management system represents the ship's operational brain and is tested extensively to confirm that it integrates all sensor inputs, evaluates threats, prioritizes targets, and directs the appropriate weapons with speed and accuracy. This involves simulating a wide range of scenarios with multiple surface, air, and underwater threats, where the system must calculate trajectories, engagement sequences, and timing to coordinate simultaneous attacks. Every command issued by the crew or the system is logged, analyzed, and compared with expected outcomes to identify any discrepancies that could affect real-world operations. After these preliminary tests, the ship moves into the weapons readiness phase, which begins with calibration and dry run exercises. During calibration, fire control systems are aligned with sensor data to ensure that every weapon will strike precisely at its target. The sequence includes checking gun elevation and bearing, missile targeting coordinates, torpedo launch tubes, ammunition feeds, and electronic guidance systems. Dry run exercises involve the ship preparing to fire missiles or guns without actual launch, allowing engineers to verify that mechanical systems, electronics, and software are fully synchronized. Any minor error in timing, alignment, or communication is corrected at this stage to prevent potential failures during live firing. Live fire exercises begin with surface-to-surface missile tests. These tests confirm the vessel's ability to strike targets at long distances. Each missile must eject safely from its launch tube, ignite at the correct moment, stabilize in flight, and follow the designated trajectory to the target. Telemetry data from the missile, radar tracking, and shipboard sensors are analyzed in real time to verify accuracy, flight stability, and system coordination. Engineers also assess how the ship responds to the physical stresses of missile launches, such as vibration, shock waves, and rapid shifts in onboard power demand. The missile trials often involve multiple rounds to ensure consistency and reliability under repeated conditions. Air defense tests are equally rigorous. The ship is exposed to simulated incoming aircraft, drones, or fast-moving projectiles. Radar must detect and track each threat, classify its type, and calculate engagement solutions within seconds. Vertical launch systems fire missiles to intercept targets, with precise control over launch sequence, trajectory, guidance, and detonation. During these tests, the ship may be maneuvering, turning, or operating in rough seas to verify that defensive systems remain effective under realistic operational conditions. The goal is to confirm that PNS Khaibar can defend itself, other ships in a task group, and critical maritime assets from aerial threats of varying speeds, sizes, and attack patterns. Gun and close-in weapon system trials form another integral segment. The main gun is tested for stability, accuracy, recoil management, rate of fire, and precision in targeting stationary or moving objects. Secondary guns and close-in defense systems are tested for rapid engagement, effectiveness against smaller, fast-moving threats, and reliability under continuous operation. Ammunition handling systems are checked for smooth loading and safe operation, ensuring that no mechanical failure disrupts the firing sequence. Guns are fired in multiple conditions, including rough seas and high-speed maneuvers, to simulate real combat environments. Anti-submarine warfare capabilities are thoroughly examined. The ship's sonar must locate and classify underwater threats, including submarines or unmanned vehicles, distinguishing them from marine life, currents, or other noise. Torpedo launch systems are tested for readiness, mechanical reliability, and accuracy in simulated targeting scenarios. Even if live torpedoes are not used, preparation and launch sequences are rigorously tested to ensure that, in an actual operational scenario, the ship can respond quickly and effectively. Electronic warfare systems are also part of the testing protocol. The ship must detect electronic emissions from potential threats, analyze signal characteristics, determine whether they represent hostile action, and generate appropriate countermeasures. These systems are tested under simulated jamming, spoofing, or interference attempts to verify that the ship can maintain operational capability while protecting itself from electronic attacks. Tests include the evaluation of communication encryption, radar signal processing, and interference mitigation, ensuring that all systems continue functioning without compromising safety or operational effectiveness. The human element is a continuous focus during firing tests. Crew members are required to operate complex systems under pressure, make tactical decisions quickly, coordinate multiple departments, and respond to unexpected scenarios. Training includes simulated emergencies, sudden equipment malfunctions, and rapid changes in threat environments. Each action taken by the crew is observed, recorded, and assessed for accuracy, decision-making speed, and adherence to established protocols. The success of firing tests depends as much on the competence and coordination of the crew as it does on the technological performance of the ship itself. Following completion of all live fire exercises, engineers, naval officers, and technical specialists conduct a comprehensive review of all collected data. Missile trajectories, radar logs, sonar readings, gun firing accuracy, electronic warfare system responses, and crew performance are all analyzed in detail. Any anomalies or inconsistencies are identified, corrected, and retested if necessary. Only when every system functions reliably, and the crew has demonstrated full operational proficiency, is the ship officially considered to have completed its firing tests. Completion of this process transforms PNS Khaibar from a newly constructed vessel into a fully operational warship capable of performing the full spectrum of modern naval missions. The ship can detect, track, and engage threats across surface, air, and underwater domains, coordinate its complex systems effectively, respond rapidly under pressure, and operate reliably in challenging environmental and combat conditions. It can undertake extended deployments, participate in fleet exercises, conduct escort missions, protect strategic maritime zones, and integrate into multi-vessel operations with confidence. The successful firing tests confirm that the ship's design, construction, engineering systems, weapons, sensors, and crew have achieved the highest standards of readiness and capability, marking PNS Khaibar as a key operational asset of the Pakistan Navy, prepared to respond to a wide range of strategic and tactical challenges at sea.